Good afternoon.
Good afternoon, sir.
Let's wait for 1 or 2 minutes. Then we'll start the session.
Sir, sir, for this the KOM activity, how many students groups it should be?
And you can work in groups like two minimum and four maximum.
And sir, we can take any mechanism like that now and explain about it. And sir, we have to show them now
Yes, yes.
working model.
If you can make a working model, okay, that will be great. Otherwise, you prepare a report on that particular mechanism, its analysis, different links, applications like that. So if it is a pandemic situation, you have to procure raw material. Okay. So if it is possible for you to procure those things, you can go ahead with a physical model. Why are not people joining? I will put a message on group. Was last session a bit late? Any idea why students, why others are not joining? It's already 4 minutes. Can't hear you, Tarun. Where, where are others? Only two people have joined. Are they attending any workshop or something? Any idea?
No, sir.
No, sir.
Okay, only three people now. I will take serious action against them. Okay, so let us start. Let us see. I will take action definitely. The attendance has become like very poor. Okay. I also wanted to give important instructions about our assignment drawing sheets. Let us see. So far we have seen this condition, okay, that there should be this relation between phi and theta maintained in all of the turning positions or turning angles. So when a vehicle takes a turn, its inner front wheel turns by more angle theta, or outer front wheel turns by relatively small angle, as it is obvious from this diagram. Okay, so they should always mention this relation between them, that the difference of these two should always come as constant. Okay, cot phi minus cot theta should always come as constant, which is equal to c upon b. So you should remember what are these parameters, what is c and what is b. B is wheelbase, easy to remember. What is c is the distance between pivot points, okay, on axle where axles are pivoted. So for example, this front axle is pivoted here. Pivot means the point where something can turn is called as pivot point. Similarly, A is the pivot point about which the axle on which this right front wheel is mounted. Okay, so that distance between these two pivots A and B is nothing but C. Okay, so whichever mechanism satisfies this equation, okay, is called as a mathematically correct steering mechanism. Okay, we will see in our further discussion that there are two steering gear mechanism. One is called as Davis gear, and the second one is called as Ackermann gear. So of these two, Davis gear is a mathematically correct mechanism which satisfies this equation at all turning angles. Okay, you take a turn at whatever angle, whether your turn is very sharp or just a minor turn, in all the turning angles, this equation is satisfied in case of Davis gear, Davis steering mechanism. We will see its construction in next slide. So here you can see, okay, so this Davis steering gear, it is a mechanism by which you can turn the front wheels of any vehicle so that you can give turn to the direction of vehicle. Okay, so here you need to identify that which links are there in this mechanism. So this mechanism consists of these links A, B. So A, B, then there is this second link C, D. Okay, you can see here. Then these two links are parallel, and third link is this bell crank like link, which is you can say BH. BH, this is the link like this. Okay, and here is the point B, and here is the point H. This is the link. Only thing is that this link is a bit extended like this in angular fashion. Okay, and this link is pivoted at point B. यहाँ पे उसको pivot किया है. Okay, means this link can turn this link can turn about which point? Point B. So as this particular link, it will get some deflection like this. When it will turn, the next position will be like this. So this arm of the bell crank lever, it will get a new position like this. Okay, so you can assume it is a complete one link. So you can say that H B N N point is here. So this is one complete one link. Okay, and the similar link is provided on the other side. Okay, here. So link AM is the another link which is slotted. Okay. Now this particular link BH is slotted link means what? That on this link one slider is provided like this, and this point is denoted as point D. So this slide is free to slide on link BH. ये जो point D है, ठीक है, point D can slide over the slotted link BH. So are you getting the construction? Like this is a slotted link BH and another slotted link is AM this way. And these two sliders are connected by the third link, that is link CD. तो ये point और ये point connect कर दिया है. Okay. So what happens that if you want to take a turn, then suppose if you want to take a left turn, then you must slide this rod CD towards left. If you slide it towards CD, at the same time the bar or rod CD is constrained to move in horizontal direction only. Means it has been provided under the guides. These are the guides. This rod cannot go away from these guides. Means this rod is constrained to slide in these guides. So if you want to take left turn, this link CD will just slide towards left. Point D will come to D dash. Point C will come to C dash position. Okay, and as this is one link over which axle is mounted, so axle will also get turned through the angle theta. Okay, so it is your mechanism. In order to understand it um, in a better way, I will show you the video. See, so you can see this is one link. This is complete one link which can turn about this particular point over which this wheel is mounted. Similarly, the same link is provided here. It is the second link. Third link is your this particular link which is fixed. The distance between these 2 points will not change. So you can call it as fixed link. And fourth link is this sliding rod. यहाँ पे जो rod है ये slide होगा in this path. Okay. So when this rod will slide left or right, depending on that, your vehicle will take turn. Okay, I will play the video. Can you see the sound? Can you hear the sound?
No, sir.
Sound is not coming to you. Okay. Okay. So just try to see the simulation.
which is guided again through the supports on the chassis.
Mm, mm.
Let's see it at work. So we are going to steer the car by dragging on this link. So both the wheels take a turn.
See how the motion will take place. ये रॉड जो है ये सिर्फ हॉरिजॉन्टल पाथ में ही ट्रैवल होगा and as this point is free to slide over this, it will slide above it like this, but its vertical position will not change. Means whatever is the height of this point from this fixed link, that will not change. It will it will slide up on this link, but at the same time this link is also turning. That's why you will not see this point to be rising up. Okay, so it will slide only, this rod CD will slide in this path. So as you will slide it with the help of some mechanism. You can also use the rack and pinion here, so that you can transmit the turning angle from your steering wheel to this rod. Okay, in between you can employ some mechanism. Just you slide this rod rightward, so this link will get tilted like this. Okay, and again here, this particular link, it will get tilted in this position this way. Okay.
And you might notice that the angle through which they are turning are not necessarily equal. Now we are going to check whether we have steered the car correctly. That can be done by extending these two lines if they intersect.
So you can see that if you extend this line of turning of these two vehicle, they will intersect here. That is the line through the axis of the rear wheel. Okay. So as ICR is coming at the same point of all the four wheels. Okay, you can say that it is a correct, it is satisfying the condition of correct steering. In at any turning angle you take a turn, in all the positions this condition will be satisfied. Okay.
And we can see this point of intersection is on the rear axle. We can zoom in and confirm it. This will be on the rear axle. So these two axles are meeting at a point, and these two wheels also have their axles meeting at the same point. So the car is correctly steered. But let us check one more position just to make sure that we were not lucky to choose a particular position where it works. So we have one more here, and
See, turning angle is again increased, and again it is found that the ICR point is coming of all the wheels at a single point. Okay, means it proves that it will satisfy the condition of correct steering in all the turning position. That is the advantage of Davis steering gear. Okay.
extend them to intersection. And indeed, again we get the point of intersection on the rear axle. So the car is getting steered correctly. By symmetry, it will also happen on the other side as well. Unfortunately, this mechanism has its drawbacks, and that is it has too many sliding joints, which are going to cause wear. And once the parts are worn out and lost their
Okay. So what is it explaining again? Is that its advantage you have seen, that of providing the condition of correct steering at all angles, but disadvantage is that it has many sliding members. So you can see that this point is sliding over this link. Similarly, this point C is also sliding over this. this rod is sliding here in these guides. So because of that, because of this sliding motion, the part will wear out soon, and as it will wear out, it will lose its accuracy, and after that it will start making the problem, because the parts will not be accurate, the condition of correct steering will not be satisfied. Okay, that's why also its construction is very complicated. That's why Davis steering gear is not in common use. Okay, the other one, that is Ackerman gear, is very popular. Okay, which is also very simple in construction. We will see that also. Okay, so I hope that you have understood that how many links are there, how is the connection established between the two links. Okay, and then let us move to the derivation of Davis gear. Any doubt do you have?
No, sir. No.
Okay,
No, sir.
No, sir.
so let's go then back to, okay, back to Davis steering gear. So we have seen already it is an exact steering gear mechanism. It consists of two slotted links, A, M, and B, H, this. And steering is done by moving link CD to right or left, whichever turn you want. Okay. And in order to effect the sliding of rod CD, you can use other mechanism like rack and pinion, etc., in order to give motion to this rod. Okay. So let us move to the next slide. Here, let us know the importance of different letters here. So what is A? A, you can see here, it is a vertical distance between link AB and link CD. So you can say A is constant, because, or you can also say that it is a vertical distance between point B and point D, because D point is only moving in horizontal direction. Vertical distance of point D will not change. That is A. Next is B. So B, already we defined that B is the wheelbase, distance measured between front and rear wheel. Okay, between the centers of the wheels is called as wheelbase. It is also a constant. Next is distance D. So you can see what is D. D you can define as horizontal distance between point B and point D. See, point B and point D, when vehicle is moving in a straight path. When vehicle is moving in a straight path like this, then what is the horizontal distance between point B and point D is denoted as D. This point D, so this distance between point D and point B will change when you will slide the rod CD to the left or to the right. Okay, so at whatever distance you slide, this point D is denoted by X. Okay, the distance by which rod CD is slide is denoted by X. Then distance C is there. Okay, this mouse is got problem. C. Okay. So C distance is what? C is also a constant. You can define it as a distance between the pivot points A and B. It is constant, it will not change. X I told you. What about alpha? Alpha is the angle, okay, between, or you can say angle of angle of inclination of the links AC with the vertical. So what is the angle of inclination alpha with the vertical when vehicle is moving straight? When vehicle is moving straight is called as alpha, and when vehicle is moving straight it is same for both the slotted link AM as well as BH. So alpha is same when vehicle is moving straight. When you will take turn, there will be change in this inclination of the links BH and AC, as one can see. Okay. So next, let us see now the derivation. We have seen that what is theta. Just a second. Theta is the angle of turning of inner front wheel. Okay, so if it is a left turn, left wheel is your inner wheel. If it is a right turn, right wheel is your inner wheel. Okay, so theta is the angle of turning of inner wheel. Phi is the angle of turning of the outer wheel. Okay, so the angle by which this link will also turn, okay, will be the same. Means theta you show here, then same theta will be reflected here because it is the same link. ये सेम लिंक है पूरा इस तरह बेल क्रैंक लीवर में लीवर फॉर्म में. Similarly, you know that outer wheel turns by a relatively smaller angle phi. Okay, so same this angle is phi, this angle will also be phi. So you can see that when you take a left turn, angle of inclination of link BH reduces. अभी कितना हो जाएगा वो अल्फा माइनस थीटा, and angle of inclination of the link AC it will increase, it will become to alpha plus phi. Okay, now depending on geometry we can do the analysis of it. So let us first consider triangle A dash C dash. See where is it is where it is A dash C dash, A dash and C dash, the changed position of point C. So if you consider this triangle, you can write an equation for tan alpha plus phi. So tan alpha plus phi is equal to A dash C dash upon A dash A, right? So A dash C dash upon A dash A into A dash A dash. What is A dash C dash? This distance A dash C dash, this distance is D plus X. X is the amount by which you have slit the rod CD, D plus X. And A dash, this distance is equal to A. Okay. Similarly, you can write other relations. Now you consider the triangle A dash C, A dash C, this triangle only of alpha. So tan alpha can be written as tan alpha will can be written as A dash C. Okay, A dash C upon A. A dash C is your D, distance D. So D upon A. Okay, and one more equation you can write, say equation 3. So from triangle B dash and D dash, B dash and D dash, only this triangle, ये जो triangle है सिर्फ इतना, उसमें ये एंगल कितना बनेगा, that will be, initially it was alpha but theta got subtracted from it, so this small angle will be alpha minus theta, that is equal to B dash D dash tan of that B dash D dash upon B dash B. So B dash D dash is your, see from this geometry, D minus X upon A. Okay, got these three relations?
Yes, sir.
Should I repeat?
No, sir.
No, sir.
Okay, so at some time I will ask you to simplify the expression. Some expression will be given and you will be asked to simplify it. So keep notebook and pen with you. Okay. So with this, let us proceed forward. Let us say, take the equation 1. Okay. In equation 10, alpha plus phi, we have d plus x upon a. We know the expansion formula of 10 a plus b. So same expansion formula we can use tan alpha plus phi के लिए tan alpha plus tan phi 1 minus tan alpha into tan phi. Okay, so put the values here. Tan alpha plus phi is what? Tan alpha plus phi is d plus x upon a. Okay, here you can write d plus x upon a. What is the value of tan alpha? So tan alpha का वैल्यू यहाँ पे दिया है d
D by.
बाई ए. सो सेम वैल्यू यहाँ पे पुट किया है. tan phi सेम रखा है 1 माइनस डी अपॉन ए. इसको सिंप्लीफाई करके ये इक्वेशन आता है डी प्लस ए टेन फाइव ए माइनस डी टेन फाइव. नाउ आई वांट यू टू सॉल्व दिस इक्वेशन, मीन्स ये वाला साइड और ये वाला साइड, एंड टेल मी द वैल्यू ऑफ टेन फाइव. टेन फाइव का आपको क्या एक्सप्रेशन मिलता है वो आप मुझे बताओ. मीन्स ये जो इक्वेशन है इसको आप टेन फाइव के लिए सॉल्व करो. व्हाट इज टेन फाइव इक्वल टू? टेक दिस इज वन साइड, ये हो गया आपका एक साइड ऑफ द इक्वेशन. It is the second side of the equation. You solve this equation, separate the tan phi. I want tan phi on one side of the equation and what is its value. And tell me the answer. I am waiting for your answers. आई होप दैट आपने ड्राइंग शीट बना लिए हैं। तो आईसीआर पे हमने जितने भी प्रॉब्लम सॉल्व किए थे 2 या 3 प्रॉब्लम्स, फिर उसका एक ड्राइंग शीट रहेगा। एक रिलेटिव वेलोसिटी पे सॉल्व किया है, जितना भी प्रॉब्लम 2 या 3 सॉल्व किया है उतना आपको ड्राइंग शीट पे बनाना है, उसका एक ड्राइंग शीट अलग बनाना है। एक्सेलरेशन का प्रॉब्लम सॉल्व किया है, उसका एक ड्राइंग शीट रहेगा, मीन्स 3 ड्राइंग शीट हो गया। और फिर हमने कैम एंड फॉलोवर के 2 प्रॉब्लम सॉल्व किए, ठीक है। तो आपको दोनों प्रॉब्लम में 2 केसेस है, वो भी सॉल्व करना है, 4th ड्राइंग शीट हो जाएगा आपका। और एक मिनी प्रोजेक्ट पे आप रिपोर्ट रेडी करो, कोई भी आप मैकेनिज़्म लो, उसमें उसे एक्सप्लेन करो, एनालिसिस, कभी उसमें डेरिवेशन है तो डेरिवेशन लिखो, ओके। एप्लीकेशंस फाइंड आउट करो, और अभी उसका मॉडर्न मैकेनिज़्म, जैसे वो मैकेनिज़्म पहले यूज़ होता था, अभी नहीं यूज़ होता है, तो अभी क्या यूज़ होता है इन प्लेस ऑफ दैट, वो एक्सप्लेन करो, ओके। सो इन दिस वे यू कैन प्रिपेयर अ मिनी प्रोजेक्ट रिपोर्ट, ओके। सो ये हो जाएगा आपका टर्म वर्क कंप्लीट। अगर आपको ड्राइंग शीट, आईसीआर वगैरह कैसे प्रॉब्लम बनाना है, तो मैंने वीडियोस की लिंक तो आपको भेजी है, आप उसे वीडियो को ओपन करके बैठ सकते हो, पॉज कर सकते हो, जैसे इंस्ट्रक्शंस मिल रहे हैं वैसे आप फॉलो कर सकते हो। सो यू कैन डू दी you can complete the term work soon, maybe next week or next practical, I don't know. We are going to start the 5th module. ये जो मॉड्यूल है स्पेशल मैकेनिज्म, इस पे स्ट्रिक्टली बोला है कि नो प्रॉब्लम शुड बी आस्क्ड, मीन्स न्यूमेरिकल्स हमको इस पर सॉल्व नहीं करने हैं, ओके। तो ये जो मॉड्यूल है ये डेरिवेशन बेस्ड है, तो अगर क्वेश्चन आया है तो डेरिवेशन के ही क्वेश्चन आएंगे इस मॉड्यूल पर। Please type your attendance also. 3 minutes are remaining. Anyone got the expression for tan phi? Tan phi equal to something. क्या आ रहा है tan phi?
Tan phi is equal to xa upon b square plus xd plus a square.
Correct. Let us check it. Okay. Where is? Yeah. Okay. So see all of you if you are getting this. So this equation we get tan phi equal to ax upon a square plus d square plus dx. Okay. Similarly, you can proceed taking this equation tan alpha minus theta, okay, tan alpha minus theta equal to d minus x upon a. So first you will expand this by formula of tan a minus b. So tan alpha क्या फार्मूला बनेगा उसका, tan alpha minus tan theta, tan alpha minus tan theta 1 plus tan alpha into tan theta, okay. And then again by putting the value of tan alpha You can put the value of tan alpha as d upon a, and then you can separate the tan theta. So I also want another formula for tan theta from you only. 1 minute is remaining, so you have to join back immediately, all of you. Okay, tell me the
Yes,
formula.
sir.
Yes, tell me the formula of tan theta. देखो ये जो इक्वेशन 3 है उसका यूज़ करो, इसको पहले एक्सपांड करो इन द सिमिलर वे। तो आपको टेन अल्फ़ा माइनस थीटा का फार्मूला पता है, टेन ए माइनस बी, और फिर टेन थीटा को सेपरेट करो। सो लेट अस सी व्हाट इक्वेशन यू गेट फॉर टेन थीटा। Everyone will join back immediately, and you know our semester is nearing to end. It is coming to an end.